Okay, welcome back everyone. Now let's continue right away with Magnus, and he will talk about Kafka versus RabbitMQ Streams. So welcome up.
Okay. Yes, welcome back. Hope you had a good coffee and some good discussions. We had a very nice Q&A between the sessions. Yes, I will talk about queues, streams, and Apache Kafka. When I did this presentation, I tried to come up with a good title, which was very hard. So I thought, let's make use of AI. So what I did was give it a prompt. There was a line of people next to Franz Kafka looking at a powerful stream of water, a futuristic image in color. This is what I got. I can see the line of people simulating a queue. I can see the stream of water simulating the streams. Franz Kafka, I don't know where he is. He might be in front of the queue there. I don't know. Anyway, that's instead of a title. Okay, so the scenario here is that you're running RabbitMQ, you're running classic or core MQs, and you're wondering what streams might be good for. In this presentation, I'll talk about the difference between stream and a normal queue in RabbitMQ. And I'll also look into why RabbitMQ Streams might be a better option than Apache Kafka. For some of you, maybe not all. My name is Magnus Landeblom. I work as a developer at 84Codes. I've been here for 7 years. Besides being a developer, I was also a project lead for one of our other products that was Cloud Kafka, so hosted Apache Kafka. So I have some experience in that as well. Based in Sweden, I live an hour outside of Stockholm. And the first image you see here is me in my home office where I work every day, which is nice. I enjoy working from home. I did that even before the pandemic. It suits me very well since I have 3 little kids at home, so it makes life very easy and I can still do the job I like. The second image is me on my second job. So outside of this real work, I volunteer as a sea rescuer and also an instructor. So this image is taken on the Swedish west coast. We actually have some sun there sometimes, where I instruct other sea rescuers how to drive a rescuing boat. Perfect second job. Takes a lot of time though, but it's fun. Okay, queue in RabbitMQ. You have a queue here. You have 2 messages in the queue. We have a producer and we have a consumer. And the rules for this is that the consumer always has to consume from the beginning of the queue, and the producer always has to produce to the end. And when the consumer consumes a message, it's removed from the queue. So consuming a message from a normal queue is a destructive action. Message is removed. This has some really nice benefits, is that it's really easy to reason about. So if you think of a message like a task, so the producer generates a task, puts it into the queue, and then you have your consumer grab the message, it performs the task, and when it's done, you can just act it and you remove it from the queue, and then you can continue on with the next one. And it's very easy to monitor. So in order to see if your consumer can keep up with your producer, you just look at the size of the queue. And if it's growing, your consumer is low and you might need to add more consumers. So it's very easy to monitor and manage. Besides all the things that Johan talked about, there are some things around it, but in theory, it's very easy. And if the consumer fails to do something, you can requeue the message back to the queue or to another queue, and then continue with the next one. So it doesn't block on one bad message or one bad task. But sometimes it would be nice that you could, if you could read a message from the queue, and when you're ready, you consumed it, it's still there for other consumers to read. In order to, if you want to spin up another consumer that should read all the messages, or if the messages in the queue are states and you try to rebuild up a full state on a new consumer, you need all the messages. So it would be nice if all the messages, for some scenarios, stayed in the queue. Another thing that you can miss in a normal queue is to allow the consumer to say where to start read from. It has to start here from the beginning, but it would be nice to start reading, skip all the messages down in the queue and start reading from the first one coming from the producer. So. And the answer to this is RabbitMQ Streams or Streams. It was introduced in RabbitMQ 3.9, so it's been around for 3 years. So some of you might already used it or heard of it. And Stream is just another type of queue. So you can specify, you create a stream queue just like you create a normal queue, but instead you set the X queue type to stream, and then you get a stream queue. This allows it to be used like a normal queue, so you can bind it to your exchange, and you can have messages routed from the normal exchange into your stream queue. So nothing has to change on the producer side. You can just continue to produce messages as normal. Things that change in a stream queue is on the consumer side. So when you read the message, it's still there. It's not removed. And it's up to the consumer to say where to start read from. So here we have that you can say, I want to read from the first message in the queue, or from the beginning, or from the end of the queue. So in the stream queue, you get both of these benefits. The one other change or difference with the normal queue is that you can't requeue a message. Since we're counting an offset here, so you specify which offset to read from. Each message has an offset. The first message in the stream has offset 0, and the next message offset 1. And the consumer specify which message to read by giving the broker an offset. This means that you cannot requeue a message in a stream queue. So you think of the task queue that we had before. If a task fails, you cannot just requeue it and continue the next one, because you always need to specify which offset to read from. In this case, you have to just remove that message, or mark that in somehow. So it's a little bit special or different. But allowing the consumer to specify an offset in this case is nice, because you can start reading from whenever. So for example, this consumer that's offset first, which means take the first message that's in the stream, no matter which, it doesn't matter which offset it has, just pick the first one, the oldest one in the stream. In this case, you will get a message with offset 1. It then continues with reading the next message, and then it's up to the consumer to say, I want to have the next message, which is on offset 1, and tells the broker that, and he gets that message back. This is done automatically in the consumer, so your application doesn't have to manage it. So you just say, I want to read a continuous amount or messages from the stream. You can also specify different types of offsets. So for example, so in the first slide, you can specify first to get the first message. You can say next, which is the next message coming into the stream. So that means skip all the messages that are in the stream and get the next one from the producer, if you just want to use. You can also specify last. That means messages from the last segment in this stream. So you have to know how the messages are stored. We'll look into that later. You can also specify offset, as we saw. Just give it a number and you get that message. And you can specify date and time intervals. So for example, give me all the messages from May 21st, and then we start there, and then up till today, and just continue streaming. Or time ago, for example. Start from 12 hours ago. Replay all the messages from 12 hours ago because something crashed and I want to have that back. So if messages aren't removed from the stream when you read them, what will happen is that you will continue to produce messages into the stream will grow. That means that disk usage will grow and eventually will run out of disk, which is bad. Most of the time that means that the broker crashes, and we don't want that. And to prevent this, RabbitMQ has 2 retention policies to specify when to delete messages from the stream. The first one is based on time, so you can set save messages or store messages in this stream for a certain amount of time. And you specify this with the Q argument that is x max age, and then you set time. Here I set 7D, which means 7 days. You can specify seconds, hours, second, minute, hour, days, month, and even year. So you can store it for a very long time. The other option is based on size. So you can say, allow this stream to be this big, which is nice because if you have, I don't know, 10 gigabyte disk, you can say, and I have one stream, allow it to be 8 gigabyte, and I have some spare room. So it's easier to calculate to allow how big they should grow. And you specify this using bytes, so x max length bytes, and then you specify a number. And here it says 500 million, so half a gigabyte, for example. You can also combine these two, so you can specify both. And the first retention policy that kicks in will take effect. One thing to note about the retention policies is how they are applied. And for that, we need to look into how we store messages on disk. So here we have 3 files. Each of them, or the first 2 files have 4 messages in them. So these segments or these files are full. And the last file only has 2 messages. And these retention policies only applies to segment files that are full. Which means that the 2 messages that are in the last file, even though they are older than 7 days, they will still be kept in the stream. They won't be removed. So don't use the retention policies like business logic. So say like, let's say 1 day, and I only get messages that are at least or at most 1 day old. Because they can be older, so you need to check in your consumer as well if you have time constraints. These files by default are half a gigabyte in size. You can specify this as well using another Q argument that is extreme max segment size bytes, and you specify that in byte as well. And these have to be in sync with the max length bytes. Since if you set the max length to lower, it doesn't take effect because it only applies to full segments. So something to note on this. Okay. How to communicate with your streams then? You touched upon it. You can use your normal MQP client, which is one real nice benefit of the streams. So the producer, just as normal, you produce messages into your exchange. It's routed through the binding keys to 1 or more streams. And you get your messages in the stream. The difference is on the consumer side. For a normal MQP client, you need to specify the extreme offset. And it's to tell the consumer where to stop reading from. And you specify, as I said, first, last, next, and so on. One thing you need to know here is that the offset for consumers using normal MQP client isn't stored on the broker. So when you restart the client, it will continue read from whatever you specify in this argument extreme offset. So you set this as first, and then you restart the consumer, you get the first message again and again. So every time you restart. So in order to handle that, you need to store the offset on some external storage if you need to keep track of it. So yeah, that's one thing. But this is for the regular or normal AMQP client. There is another client called the stream client. It uses another protocol built for stream queues. It allows for batching, so it's much faster than the normal AMQP client. And this one allows for server-side storage. So you tell it to start from the first offset, and it will read a couple of offsets. And if you restart it, the broker will know where you left off. Or you need to tell it, for example, when you read 100 message, you commit your offset using ACK feature, and you commit it to the broker, and then it stores that, okay, this consumer has read this and this is on this offset. and then when you restart your consumer, it will continue from that offset. Which means that the more frequently you commit your offset, the more up to date will the broker be and know where you are at. But the more frequently you commit, the more size or the more disk will be needed to store the offset, because offsets are stored in the same segment files that we looked at as the queues. So the more often you commit, the more disk will be used, but the less you commit, the less up to date the broker will be with your offset. So let's say that you have read 98 messages, and then the broker crashes, or the consumer crashes, and then we start from 0 again. So only from the last commit. Okay, scaling streams. Streams is about speed or throughput, so a high amount of messages. And in order to support that really well, you need to allow for scaling up to multiple nodes. And RabbitMQ supports it. It's supported using a feature called super streams, which allows you to group multiple streams into one group. So the producer and the consumer only see it as one stream, but it's actually multiple streams on different servers. This was released in RabbitMQ 3.11, so it hasn't been around for that long time, but 3.11, 3.12 is the recommended versions now, so you should all have it. This works by, it's up to the producer to decide where to send the messages. So considering you have a super stream with 3 streams in it on 3 different servers, we only have 2 here, but that was because we had a small, I have a small screen. It's up to the producer to say where to send the message. And by default, it does this by using the normal routing key. It hashes that routing key, and based on that hash, tell it which stream to send it to. So a very good idea here is to use, for example, an account ID or a customer ID or something that something like that. And if you hash that, you only get the same hash value, which means that all the values or the messages for that customer will end up in the same stream. That also means that all the messages will be ordered. It might be mixed with other customers, but they will always be in order, so you can apply them. And for other customers, might end up at another server, hopefully well distributed. And on the consumer side, you have your application, you spin up a consumer, and it will connect to all the servers that have a stream that's part of this super stream and consume from it. So you will get all the messages into that application. That's handled by the consumer. But one thing that's pretty normal, or in normal cases, producing a message or generate a message is very fast. Consuming a message is normally slower because it's on the consumer side, you have to do your work, which means that you can also have, most of the time, have one producer and you need many consumers in order to keep up. So here we can scale the number of servers. You also need a solution to scale the number of consumers. And you can do that too with streams using something called single active consumers. It's a lot of arrows and dotted lines and stuff here, but I'll try to explain. So you have the same 2 streams. We have one application, but running it as 2 instances here. So we see that, oh, one consumer isn't enough. We spin up another replica of that application. So we have the same 2 consumers. Both of these are part in the same consumer group. You specify that using an argument here. I don't remember exactly what the argument is, but so they form a group. And using this single active consumer, that will allow for only one consumer from this group to consume from that stream. So for example, if we look at the blue consumer in application number 1, that's the one consuming messages from the first stream. The blue consumer in application number 2 has a dotted line. That means it's just idling. It's connected, but it doesn't consume any messages. So the consumer in application number 1 will get all the messages in order. If I were to allow both of them to consume, I would get messages for one customer on both applications, and it might be happening in the wrong order. But here I get one consumer getting all the messages, and application number 2 running maybe on other server or somewhere get all the messages from the second stream. And that way I can scale up. So I have two nice things here is that I get all the messages ordered. I have another consumer just idling, which means that if application number 1 dies, or if I kill it or restart it, whatever happens, application number 2 will just continue reading the messages from the first stream as well. So I always have my consumers, but I always only have one, so I have it in order. And I can just keep adding more and more applications here in order to scale this. But since we can only have one consumer and one stream, if I have 2 streams and 3 consumers, I will have the last application just sit there waiting, which might be fine if you want to have a backup or if you start consumers often. But rule of thumb here is the same amount of consumers as you have streams, so they are always working. Okay. And some of you might know or have heard of Apache Kafka and are thinking, yeah, this sounds a lot like Apache Kafka. And I agree. They are very much not the same, but very similar. Apache Kafka has been around for a longer time and is more known in the streaming world, but they handle the same type of use cases. And I think that's why RabbitMQ builds streams, in order to be in that same space and compete with Apache Kafka. For example, we have a stream, which is similar to a partition in Apache Kafka. And you have a super stream, which is similar to a topic. Topic in Apache Kafka is a grouping of partitions. Yeah. One thing that's a difference, or big difference, I would say, is configuration. So in Apache Kafka, you have a lot of configuration settings you can do. You can configure your producer, you can configure your consumer, and you can configure even on the topic level. So there's a lot of configuration settings you can do, which can be really good because you can adjust it to work just as you wish. One configuration thing that stands out, and I think that's really a really nice feature in Apache Kafka that isn't available in streams, is the cleanup policy, also known as log compaction. So what this does is that you produce messages into a topic, and in Kafka you specify a message key and a message value. And log compaction will allow you to, when the retention kicks in, so you start cleaning up the messages, it will always save or store the last value for each message key, which means that eventually this will become like a key value store. So if I use as a message key, I can use for CloudAMQP, I can use this server name, for example, and then I can put some configuration, and it will always keep the last value based on each key. I will eventually have a key value store with the server name and a configuration. And when I want to update it, I just publish a new message into it, and I will get a new updated key value. I think this is a really nice feature that I know a lot of people use in Apache Kafka. This isn't available in RabbitMQ. I don't know, RabbitMQ Streams. I don't know if it will be available, but it's a very nice feature, in my opinion. So it's sometimes good to have a lot of configuration options. Another one is scaling. Apache Kafka is known to scale very well. It was built to run on very small servers, even old infrastructure, but you can scale it horizontally. So you can have many servers running, and you can scale up on that. And now when they're moving away from Zookeeper into using Raft, they will be able to scale even further. I read that aiming at supporting 1,000 partitions per topic, which is a lot. But it scales very, very well. It's easy to handle the scaling, both scaling up and scaling down, and Kafka cluster. And also the ecosystem for Apache Kafka is much, much bigger when it comes to the streaming world, the streaming features. For example, you have Kafka Streams, which is like what's called I lost the word. Sorry. It's a consumer producer, and you get a very nice high-level API to processing messages in a stream. And you also have Kafka Connect, which allows you to connect your Kafka cluster to Postgres, to RabbitMQ if you want to S3, to whatever you can, which means that Apache Kafka really becomes this central hub in your infrastructure because of Kafka Connect. So that's really nice. And it also has a lot of streaming integrations, both companies building products that integrate with Apache Kafka, but they have a bunch of open source ones like Hadoop, Spark, and Flink, and all these stream processing frameworks that connects really well with Apache Kafka. I guess this is because Kafka is much bigger in the streaming world. Everyone who thinks streaming think Apache Kafka, and RabbitMQ Streams is younger and newer. So eventually, if we put some work, maybe we can compete in that as well. But right now, Apache Kafka is much bigger. Okay, benchmarking. It's always fun to compare, but also really difficult. I try to do this as simple as possible. What I did in order to compare RabbitMQ Streams and Apache Kafka, I created a 3-node big bunny cluster on CloudAMQP. I created one stream on one server, and then it replicates to the other two. I also added more disk, so I added I had a 0.5 terabyte disk on that. And then I created a similar setup using the same instance types, same disk, and then I installed Apache Kafka on that using the default configuration from CloudAMQP, in order to have the basic, so for you, if you create a cluster, you will have hopefully the same benchmark as I did. So no changes. I didn't do any optimization to give you really impressive numbers. Message size is 100 bytes, so quite small, but I did some. I also disable all retention. You don't have to specify retention. You can skip that. I did it here to don't have any background job running while I did the benchmarking. So only focusing on data in and out. One note here is that I also ran the benchmark inside VPC. So I created my big bunny cluster in VPC, and then I paired it and ran it there. So without encryption. And this is the results. I even highlighted the faster ones, so it's easy to see. But as you can see, RabbitMQ Streams, 490,000 messages, both in and out in parallel. Apache Kafka, 594, so 100,000 messages per second faster. Same infrastructure. 60,000 messages faster in consuming. As I said, benchmarking is hard. If you did the same, you'd probably get another number. But it is just to showcase that both are really, really fast. But Apache Kafka is a little bit faster on the same infrastructure. Yeah. Okay. So Apache Kafka has more configuration options. It's a bigger ecosystem. It scales better. It's faster. So why should you use streams? Huh? No answers? No? It's kind of hard. I have some points here. One thing is one cluster. In RabbitMQ, you can spin up your RabbitMQ cluster. You create your normal classic queues or quorum queues, depending on your needs. And then you see, I have a use case for streams as well. I can use the same cluster, just add the stream queue. And if I have a multi-node cluster, I can even add a superstream to have it scale it out. And when you run into bottlenecks, you can just scale up instead. So this makes it both easier to monitor. Less infrastructure is good. It also makes it cheaper. If I were supposed to run a RabbitMQ cluster and a Kafka cluster, it would be at least twice as expensive. This is one. And you can scale up if needed. I'm sure you need. That's nice. You can even use an MQTT plugin, so you get MQTT messages into the streaming world using one cluster. That's a really good benefit, I would say. Another one client library. As I mentioned, you can use your normal AMQP library. Just create a stream queue, and you can start reading from that. At least the producer, it looks the same. Just stores the messages, and then you can choose if you want to use your AMQP consumer or using the stream consumer. So you can have the normal AMQP producer on this side and have the stream consumer if you want to have the server side offset storage thing. Another one, management interface. RabbitMQ comes with a built-in management interface. You can monitor queues. You can create queues, you can delete queues, you can see all the connections, you can see data in, data out. And even for stream queues, you can see number of messages in the stream. You can see how it replicates in the cluster. So you get a lot of visibility in a web interface, which is really, really nice. In Apache Kafka, it doesn't have any built-in interface. There are 1,000 open source UIs that you can install and try to run. You need to learn every one of them, and they work different. And I think there is even some that you can pay for, which might be really, really nice. But here it comes free for it. You just use it. Another one. Less configuration. Less configuration can actually be a good thing, because there are less things that can go wrong. And the default configuration for RabbitMQ Streams and the ones that I showed you, max size and max age, and it's good enough for most general purpose streaming. So you can at least get up running, and you can have your streams set up. And it's less to think about. And also for the consumers, or the clients, there's less configuration, so it's easier to manage. And fast enough. You had 100,000 messages difference on the producer side, but still 490,000 messages per second is quite a lot. So maybe it's fast enough. That's up to you to decide. It's not up to me. And if you need more than that, you can also just have a bigger cluster, which would allow it to be faster. Yes, LavinMQ. Johan talked about it. Christina will talk even more about LavinMQ. It also supports stream queues. Comes bundles, you can just create it like normal in RabbitMQ Streams. As of today, it doesn't support offset storage for the normal AMQP client, but we're working on it. So soon you can use your normal AMQP consumer, and you can store the offset on the server as well. So you get all the benefits there. It doesn't support the streaming client, so it only supports the normal AMQP client. And using a stream queue, normal AMQP client on LavinMQ, I got similar setup. I got these benchmarks of 332,000 messages. So it's lower, but think about that this is using the AMQP client, not the streaming client. So I would argue that that's because it's slower. But it's still really fast. And what you can do here is you can run your application as you do today. You just change it from using a classic queue or a core queue to a stream queue if you want it, if you have the use cases for it, and you can continue work as normal. So there is very little change needed in order to go from normal queue using a stream and get these numbers, which I think is really, really nice. Yes. And I know everyone touched upon this, but some use cases for streams. First, we have large fan out. So if you have messages that you want to send to, let's say, 1,000 consumers, what you do if you have normal queues is if you set up a fan out exchange, you connect 1,000 queues to that exchange, and then you have one consumer for each queue, which it might work, but it's probably not the best solution. If you use a stream instead, what you do is you have one exchange, you have one stream, and then you connect 1,000 consumers to that stream. And each consumer has its own offset, which means they all work in, they can all work the same time on the stream and just reading messages. So you still have same amount of connections, but you only have one queue instead of 1,000 queues. So I would save some resources. Replay. Since all messages are stored in the stream for a defined time or size, if you have an event-driven architecture and each message consists of some state that you build up your applications on, if you want to spin up another application that does something and it needs to rebuild the state, it's very nice to have a stream, because then you can set your offset to first, and then we start read from the first message in the stream, and it consumes all the messages, and then you can build up your state in your application, then you can just continue on. This also allows RabbitMQ Streams to act like a single source of truth. You publish all your message in there, and then you can spin up a consumer that reads the state or the state of the world from the stream, and then you can also consume from that message. So having it persistent could be a real benefit. And as we see the throughput, using the stream client on the stream queue, it's much faster than using a normal queue and normal MQP client. So if you have a high throughput requirements, the stream is good. Large backlogs. So queues are built to be short, and then I mean classic and quorum queues, they're built to be short. And best of worlds, you keep it at 0, so the consumer keeps up with the producers, and the queues are very short. And if you feel like I need to keep more messages in the queue, then maybe a stream queue would be a better option. Yes. And RabbitMQ Streams is available today on CloudAMQP, both on our dedicated instances, so you can spin up any size, and then you can start creating your stream queues. What we recommend is that you use at least 3 nodes, so you get the replication of the stream, and you also add some extra disk space, because the streams are built to, for this message to disk, you need more disk space. By default, they are quite small disk, but you can add more. And you also need more nodes in order to support the super stream, so you can actually scale out. So at least 3 nodes. It's also available on the free plan, or the Tiger, but the free plan. So you just want to try it out, you can actually use it there. Yes. That's it for me.
We have some questions online.
Okay, so the question is, do you also specify extreme offset when consuming from a specific date and time? So when you're using the AMQP client with the stream queue, you need to specify where in the stream to start read from, and you use this argument, extreme offset, and there you can specify the number or offset, like an integer, so 0, 100, whatever. You can set first, next, which is next message coming in. You can also set the time, and you can set time interval, so 12 hours ago. And I guess this looks different between different languages. For example, if you have a type language, you give it, for example, Java, you give it a Java date, as a date, and then the consumer will translate that for you. But that looks different from different consumers. But yes, you specify. Next question. Can you somehow have a stream in one RabbitMQ instance consume messages from an exchange from another RabbitMQ instance? Can you have a stream in one instance consume messages? I have to think. You should be able to have an exchange federation. So you publish to. I would like to see some heads nodding here. If you have an exchange, you publish to the one, and then you federate all the messages from that exchange to another exchange on another cluster, and there you have your stream queue. That should be possible. That answers your question. But I thought I found out there. So. Yeah.
Yeah, I'm not. I don't think that's fully supported yet. But one thing that you can do is you can use a shovel, and you can shovel. This brings up an interesting use case where you publish to the stream, and then you shovel to regular AMQP 091 queue and then consume there. So then you can get very high publishing rates in, and then you can also have these destructive reads on the queues. So that's another nice use case, which is CPU efficient.
Hi, sorry. Just to clarify the last one with the shovel. So I could have a stream on my cluster, and then I just have the regular queues from which applications consume their messages, and just shovel all the messages from the stream space on some routing key or whatever I like. All right. Thank you.
No questions there.
If there's someone online who wants to ask a question, just unmute yourself.
Good.
Yeah, can I ask? Can you hear me?
Yes.
Thank you for the presentation, firstly. And I want to ask a question. I am novice in the Kafka and RabbitMQ Streams. Frankly speaking, I have zero experience on them. And thanks to RabbitMQ core features, I handle everything with the regular feature set so far. Maybe the project that I involved so far were not perfect with. It is possible to share some real-life use cases. You already mentioned some use cases, but what is the real need based on your experience?
So, real-life use cases of RabbitMQ Streams. Is that the question?
Yes, you are right.
I have a use case here.
Don't we have one customer that collect all the data from how users are navigating their web shop? They are selling shoes or something like that, and then during the night they go through this stream of how users have used, so they can reread the messages, and then they analyze them and can send out like newsletters to that specific person about depending on how they have navigated on the website.
Yeah, that's true. Yeah, so if you have, when they track a customer on the website, in real time, they can send out messages. So for each event on the website, they send a message to the broker or to the queue. And in real time, they can send back to the web page and give so-called ideas like, oh, you looked at this shoe, maybe you should look at this shoe. And then later on, since this queue is persisted, they can later on run a batch job during the night to gather all the messages that has to do with shoes based on this customer, and then generate an email and send it out later on. Hey, you looked at these shoes. Maybe this could be good for you if the customer hasn't buy anything. Which was that use? Thank you. Okay, Johan.
Yeah, we can. One of our customers is using it for, well, a fancy way to say it is a telemetry of a very special yeah, so telemetry data for some unit in the field that's being tracked. So you can think of it as Fitbit for a certain use case.
Okay. Thank you so much to Magnus, and thank you everyone for the great questions. We will now have our second break, but just like last time, we will host the online Q&A. So everyone online, please stay put because Magnus will stay here and answer even more questions.
So we will run another Q&A. This time we also added in Christina.
Hello, everyone.
Who will be talking about LavinMQ. Do you want to say a few words about yourself? Just one sentence before we start?
Sure. I'm Christina. I'm a developer on our Crystal team, so I work a lot with LavinMQ.
So, Mange, you mentioned Kafka Connect among other features that are really great in Kafka. If you could choose one feature from Kafka that you want to add quickly into RabbitMQ Streams, what would that be?
Yes, Kafka Connect or Kafka, or both?
Kafka Connect.
Kafka Connect.
No, you said Kafka Connect is one of the benefits of
okay,
Kafka.
yeah.
Which one would you like just take? And
Yeah,
put into
the one I would really like is that log compaction feature. So in order to imagine you have a stream, you publish messages with routing key, and for each routing key, you always persist the last message. So you build up this key value store. I see a lot of use cases where having a key value store that's always updated. You just produce new messages all the time, and it keeps the key value store always updated. That would be a very nice feature. And I can see a lot of use cases for us and a lot of customers I talk to that could make use of this.
Thank you. Another question. You also said that one cluster is a benefit of RabbitMQ. Would you say it's easiest to get started with RabbitMQ Streams, Kafka, or LavinMQ with Streams?
That's a good one. Maybe a bit biased. I have more experience with RabbitMQ, but I would say get up and running with RabbitMQ or LavinMQ is equally simple. Both if you use CloudAMQP, but also just download RabbitMQ, install it on your server, and start it up. You have everything there. With Apache Kafka, it's very easy to download and start it, but there are some things to consider from the beginning that you can't change later on. And there's more terminology that you need to learn in order to get it around. Yes.
You want to fill in?
Yeah, no, I think what Magnus said with the configuration is also something that you can consider. Like less configuration, sure, you have less power to mold it into what you need for that specific moment. But when you're just getting started, it's easier to just get something up and running if you have less to kind of fiddle around with and potentially do something wrong. So yeah.
While talking about LavinMQ and RabbitMQ Streams, do you think there is a huge difference between LavinMQ Streams and RabbitMQ Streams?
Not a huge difference. There are small differences, of course, in how it's developed. And of course, LavinMQ is a much younger product. So there are some things that can be added to LavinMQ Streams, but I wouldn't say that they are super different.
Yeah, I agree. The functionality is most of it the same. I mentioned the feature where you can store the offset broker in LavinMQ, which I think is it makes it easier to get started. And then on the other side, RabbitMQ supports the Stream client, so it's faster. But otherwise, I think it's quite similar.
If you would give one advice to someone who is who wants to start to use RabbitMQ Streams like today or LavinMQ Streams, what would that advice be?
something specific they should think about or
Yeah, I think
configure?
this goes for streams, but also like just the entire software is to really understand what you're doing from the beginning, read documentation, do our training tool that Erica is going to be talking a little bit about in the next session. But just, yeah, kind of read through documentation and understand what you're getting yourself into before making a lot of critical decisions.
Yes, I agree. There is a lot of built-in features in both LavinMQ and RabbitMQ, and RabbitMQ also has support for plugins, so you can add even more. So before you set up, don't be too quick to set up on, I want to have it work like this. Read up so you understand how it can work, and maybe ask someone who knows RabbitMQ really well. Is this a good idea? Is this a good setup? Because it might be good now, but if you scale up later on, for example, the use case that I talked about with many queues, large fan outs. When you have 10 customers fanning out, have one queue per customer and just fan out the messages you send to them. Looks like a really good idea in the beginning, but then you become 100 customers, and it goes really well. 1,000 customers, 10,000 customers. Running 10,000 queues with the fan out exchange isn't very good. But since you have built your infrastructure that way, it might be even more difficult to change it when you have 1,000 customers. So do this before you reach the critical point.
Do you think fan-outs will stay in RabbitMQ and be something, or will it go and be in streams totally?
I see very little use of fan-out. So in my opinion, you can use the topic exchange or streams, and then you're good. That's enough.
We have a question or a comment here. Can we kindly ask for a workshop at another event, maybe? Yes,
Yeah,
it should,
sure.
of course, be possible to set up.
I think that's
Of
a good
course,
idea.
a really good idea. Thank you for that. We have RabbitMQ 4.0 coming. Will there be any changes in the streams, stream queues in 4.0? In version 4.0? Anything you're aware of?
No, not that I am aware of regarding stream queues in 4.0. No.
Okay.
But I haven't looked into it that much either. But I know there's big changes coming, but hopefully streams will.
Yeah, I asked that question to Annie and Johan. What will be the most interesting new feature coming? Do you have any comments on that?
Yes, I'm actually really looking forward to. They talk. There's been a lot of talk about disabling metrics in the management interface. Johan mentioned it, that you can get some nice performance benefits by disabling the metrics because it's a very costly operation. So, in the idea in 4.0 is that there will be no or a lot fewer metrics in the management interface, and they will use Prometheus to gather. And this allows us or everyone to gather more metrics, more information. So we can have. You need to look at it in some other place, but you can get more details and information.
Okay. I think we have to stop with questions now, but thank you so much. Thank you online. We will let the other people come into the room again and keep going with Erika.
Thank you.
Thank you.